In this chapter, we're going to look at the graphical representations of data. In this lesson, we're going to look at a special type of graph called a histogram.
In this particular lesson here, we're going to take a look at histograms, okay? Which is a type of graph, and in fact, it's a type of bar graph. It's very, very similar to what you would have looked at before called a bar graph, with some key differences. Now, with a bar graph, what you might do here is you might have, I don't know, a graph here we're talking about ice cream, okay? So you might have, for example, here's our chocolate, and we did a little count here, and it turns out we've got 5 people like chocolate. Let's say you've got strawberry, so 3 people like strawberry, and then, I don't know, vanilla, you've got, I don't know, let's say 10 people like vanilla. And so we counted those all up here. Along the x-axis here, the independent variable is going to be the type of ice cream. Order doesn't matter, okay? It's these definite categories of items that we're counting and whatnot, and we identify the number, the frequency, okay, or the count along the vertical axis, the dependent axis here. Now, with a histogram, the independent variable, okay, is continuous. Now, what we mean by that is it can take on anything, any value within a range of values. Okay, that's a little bit different here. Okay, it's not like when I talk about ice cream, it's taking on like any value in a range of values. I don't really even talk about it like that. These are categories. So here, what we're talking about here is I don't know. Maybe we're talking about length. Okay. And let's say we're talking about, I don't know, let's say the length of a bunch of dogs here. We're out at the dog park and we're doing some statistics here, and we're just measuring dogs, okay? And so what happens here is we're going to create these bars, but along the x-axis here, what we do here is we're still going to create bars, but the width of each bar is going to represent a range of values. I don't know, let's say we go from 50 centimeters to 75 centimeters, 75 to 100 centimeters, and so on, 125. And then what we do is we then, like the same thing over here where we're counting them, okay? So we counted the number of people that like chocolate, and then we build a little bar that goes up to it. We're going to count the number of dogs that are between 50 and 75 centimeters and put that up to here. But the thing is, in a histogram, the one bar leads right into the next one. So we go from 50 to 75, and then we go from 75 up to 100. So our bars are right up against each other. So let's say that this was 5, and maybe this was 8. We have 8 dogs that are in this category. Now, I don't really care where in that category. I can, if I wanted to be a little bit more specific, I could have made my bar here a little narrower so that it's a little bit more specific, but maybe this is all I really need for my whatever purposes I have for this. And I'm just counting the animals and determining how many are in this little range here. You got to be a little specific, like is this 50 to 75 including the 50 or including the 75? So normally what we do is we would go from 50, including 50, up to, but not including 75, and then the next one would be 75 up to, but not including 100, and then 100, and so on like that. But the key thing here is that our bars are right up against each other because the data that we're inputting for our independent variable is going to be continuous. Okay? So anyway, so for example, another example here might be the time that an airplane can arrive at an airport. That's an example of continuous data. It can be at any given specific time that you can measure. So normally what we would do is we would chop it up into little ranges that we're interested in, just tally the number that are in each one of those little ranges here. The width of the bars on the histogram represents that range of values. Okay, so the wider the bars, okay, the larger the range there that we're counting in. Okay, the smaller, the more specific, the more detailed, but probably the less that you're going to count in each bar here. So since the data is continuous, the bars are always together or joined. In this case, there's no spaces in between. It makes sense to put spaces in between a regular bar graph because there's no connection here between like the group of chocolate likers, the group of strawberry likers, the group of vanilla likers. There's no connection, nothing that would join those together. I can put them in whatever order I want. Okay, it's not like one leads into the other here. So it actually communicates something to separate them out here. Here, if you saw separation in a histogram, what that would mean is, so for example, let's say I have, and then I have something over here. That empty spot there means that there were no dogs that were measured between like 125 and 150 centimeters. Okay, that's what that would communicate. Here, those spaces are just so that there's a visual separation between them. And then finally here, bars on a histogram are almost always vertical. Okay, yeah, we don't typically take histograms and write them sideways. They're almost always going to be vertical. That's the most common way that you would see that. Okay, so this question here says, the histogram below shows the number of airplanes scheduled to arrive at the Calgary International Airport on a particular day. Okay, so, and remember, there's our title. Got to have a title. And then we've labeled our axes here. It's going to be time. Okay, and time is a continuous variable. And then over here we have like the number of airplanes for those given time slots there. Now, it's probably not a bad idea for us to have a quick look down here and take a look at the scale. Okay, and if you are able to take a look here, it's 6 o'clock here, 7 o'clock, 8 o'clock, 9 o'clock, and so on. And so each of these little blocks here has got the width of an hour. So that's basically the scale that we're working with here. Each of our bars here is an hour wide. So how many airplanes are scheduled to arrive between 2 p.m. and 3 p.m.? Now 2 p.m. and 3 p.m. On the scale here, this is a 24-hour clock here. So 2 p.m. is going to be 14 and 3 p.m. will be 15. So we're looking for between 14 and 15. And so down here, here's my 14. Here's my 15. So I'm looking at this bar right here, and I just go up and come over here and notice that it's 4. Okay, I'm expecting 4 airplanes, okay, to arrive between 2 and 3 in the afternoon. Now, the second question here is a bit of a typo here. This is a repeat of the question that we just did. So let's just skip that and go to the next one here. The question is, what are the busiest times at the airport? Okay, busiest times. Well, that's going to be where the most airplanes are coming in. So we take a quick look up here, and that is going to be between, if we look at this bar here, between 11 and 12. So down here we're going to say from 11 a.m. to 12 a.m. To 12 p.m. actually. Okay. And then here we've got from 3 or 15 to 16. So 3 to 4. So 3 p.m. to 4 p.m. Now, it's not to say that what's going on between 4 and 5 isn't a lot. It's just not the busiest. Then from 5:17 to 6:18 is our next one. 5 p.m. to 6 p.m. And then notice there's this huge drop here. Okay. Now, how many, the next question here that's related to this, it says, how many planes are scheduled to arrive during those times? Well, for each one of those, we just got to go look at our scale here. Remember, so the time is on the x-axis, so we're going to go up to the top, slide over, and it looks like we're expecting 10 planes. Okay, 10 airplanes in each one of those time ranges there to land at the airport. There's a couple more questions we're going to ask here. So our next question says, what is the quietest time? In other words, what time during the day do we see the least amount of activity here? This requires a little bit of careful reading here. So notice on our graph here, our scale, notice that right here, this first time is 0:00. That actually refers to 12 o'clock a.m. And then there's this jump to 6 o'clock a.m. Okay, so what's happening here is the width of this bar here is the scale has changed a little bit. So basically whoever's putting this together, there's so little information coming out of this section right here that it was just collapsed. So this is actually, each one of these bars here is an hour, except that one. That one there is actually like 6 hours worth of data there. And there's only 2 planes that go with that particular bar here. So what's the quietest time? The quietest time is going to be from 12 o'clock a.m., so midnight, to 6 o'clock a.m. Now, Are there planes scheduled to arrive between 4 a.m. and 5 a.m.? The answer is, I don't know. I don't know. You can't tell. Okay? You can't tell. I can't tell any more specific than this. Just like based on the graph right here, I know that between 11 and 12, okay, in the morning, I know that 10 planes are going to land. But I don't have any detail any more specific than that. I don't know if there's going to be any planes that land, for example, within the first 10 minutes of that hour, from 11 to 11:10. I can't tell. I can't tell in this bar if there's going to be any planes between 4 and 5. This gives me a range that goes over top of that. The information isn't detailed enough to give me that sort of information that I'm looking at, that I'm looking for, I should say. So yeah, so in this case right here, I really don't know. Maybe. Okay, what I do know is there could be 0 to 2 planes here. I know that there are 2 planes that land between midnight and 6 a.m. But I'm not sure when they landed. It could be that none of them land between 4 and 5. It could be that one of them lands between 4 and 5. It could be that both of them landed between 4 and 5. I really just can't tell. So that's a little bit of a limitation to our histogram. Okay, depending on how fine your graph is, how wide your bars are, determines kind of the level of detail that you're looking at. So in this question, we read, the histogram below shows the amount of money that a household in one province spent on home renovations during the past year. Okay, so we're looking at single homes here and how much they spent here. So we go from 0 to 100, 0 to 1,000, 1,000 to 2,000, 2,000 to 3,000, and so on. So you can see that our bars here, for the most part, are $1,000 wide here, and they're all the same here. In that previous one here, now notice up here though, this is 5,000 plus. Okay, so from this point on, this bar basically goes for a lot longer than that. So sorry, I should correct what I said here. These bars are all $1,000 in width. This one up here really is quite a bit longer than that. Okay, 5,000 plus. So how many, and I remember, sorry, I should say this again here, money is continuous. Okay, to a degree, money is continuous. Okay, the smallest unit that most people work with is the penny, so 1/100 of a dollar. But in this case here, it's convenient to think of it mostly as a continuous value here. And so these are going to be the number of households. So this is like a discrete measurement. Down here is more like a continuous one here. So how many households spent less than $1,000 on renovations? Well, less than 1,000 is going to be this bar right here, from 0 up to 1,000. And, well, that's tough to say here, okay, because this right around here, if I slide this over, this is going to be my 500. This is about where 500. I mean 50. I don't know why I said that. This is going to be about my 50 scale here. My 100 is going to be about here. So I don't know. If this is 150, this is maybe halfway in between. So let's say 125 households. It's a good guess, okay? It's a fairly good estimate. I really can't say beyond that. It's about halfway in between. What is the most common amount spent? Well, remember, most common is going to be that range that has the highest frequency, the most people in it, or most households. And in this case here, it's going to be between 1,000 and 2,000, because in this case here, that's going to be just over 250 households here. So we're looking at between $1,000 and $2,000. Actually, I'll write it like this: from $1,000 to $2,000. Now, what's the highest amount spent? Well, the highest amount that was actually spent here was 5,000 plus. Now, we don't know exactly. Okay, this doesn't tell us where that ends. I don't know what the upper bound on this is. So the best I can say is the highest amount spent. Not sure, but it's more than $5,000. Okay, that is about the best I can say. I can't tell, based on this graph, what the upper bound is on that particular bar. And again, so there's a level of detail that I don't get out of the histogram. Okay, and that's what that's really trying to point out here. Okay, there is a lot of information, but for example, I don't know how many houses here spent, let's say, between 4,500 and 5,000. I don't know. You can't read it like this. All we know is that in this group right here, it's this amount here, just under 250 people spent between 4,000 and 5,000. I don't know any more specifically than that. Okay? Okay, so for this question we read, the histogram below shows the number of movies attended by people in different... Now it says age groups here, but really what we're doing here is the histogram here shows the number of people that saw a different number of movies. Okay, so this is the number of movies attended. So we've got people viewing between 0 and 10 movies, 10 to 20 movies, 20 to 30 movies, and so on, up to 80 to 90 movies. Okay, so... Again, it's the number of people that saw that many movies here. So first of all, how many people were surveyed? Well, sometimes what they do with histograms here is you're going to see them put the number of people represented by the bar on top of the bar. It just makes for easy reference here. So if I want to figure out the total number of people surveyed, I just have to add up those numbers here. And when you add 7 plus 9 plus 10 plus 9 plus 8, 6, 4, 2, 1, you're going to get 56 people. Okay, they surveyed 56 people. Now, next question here. How many people went and saw at least 7 movies? Okay, 7 movies here. Now, man, that is a tough question to answer. And in fact, we really can't answer it exactly. Okay, we cannot give an exact answer. And the reason is because these bars here are broken up in terms of 0 to 10. There's no finer scale division there, so 0 to 10. So, I mean, all of these people saw more than 7 movies. All of the people represented here, and when you take a look at that, if you add up all of these numbers together, that is going to be 49 people. We know that 49 people saw at least 10 movies. Okay? I know that because of this chart here. Now the thing is, the 7 people that were in here, I don't know. I don't know. Did all of them see 8 movies or 8 to 10 movies? I don't know. Or so I guess it would be 8 to or 9 movies here. Maybe none of them. Maybe none of the people represented here saw more than 5 movies. I don't know. So the best that we can say here is we know that somewhere between 49 up to 56 people saw at least 7 movies. Okay? We cannot be any more specific than that because of the way that the information is given in a histogram. And again, that's okay. That's okay. That is just a limitation of the histogram. Okay. Now, this question here wants us to build the histogram. So the following data represents the ages of prisoners and their current jail sentence. Draw a histogram with the data provided. So what we're going to do here is we're going to put age on the x-axis because this is our continuous data here. And the sentence here, well, the sentence, like normally you think time would be the continuous data here, but in this case, the way it's set up here, remember, they're going to give sentences basically in these whole month groups here. So anyway, so this is going to be sentence, basically sentence versus age, okay, for prisoners. So now down here, when I look at my scale here, look at my numbers here, I think I can go up by 5s and make this work here. So in terms of age, and this will be in years, this will be 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75. And I don't think we go beyond 75 here. Now, it's important for me that I make sure that when I'm building this, it's helpful for me, I should say, that I go up by a constant scale, because if you take a look here, notice that the jump here is bigger than the jump here. This is a jump of 7. Between 25 and 18, that's a jump of 7. Between 26 and 30, that's 4. This is 4, 4. This right here, okay, 41 to 50, that's a jump of 9. So the age ranges aren't consistent. So it's important for me to keep my scale consistent, so that when I look at my bars, when I see that one's a little bit wider, well, that communicates something to me. Okay. Now over here, I'm going to put my sentence length, and this is going to be in months. Actually, I want you to be able to see more than what you're seeing here, so let's zoom this up a little bit. And I'm going to go up by 5s again. So 5, 10, 15, 20, 5, 30, 35, 40, 45, and 50 is the, well, no, 55, 55, 60 is the maximum we get up to, so up to 65. Actually, 5s was a good one for me to go to. Maybe I'll go a little bit higher here. Okay. I keep twisting it. Every time I do that, I twist it just a little bit. Okay. So my first one, age 18 to 25, there was 54. So 18 to 25 is going to be somewhere from about here up to 25. So, and I go up to 54, so just a little bit shy of the 55 years. So it's going to look something like this. Now, clearly it would be better for me to have a ruler, but there I go. So there's my graph right here. Now, then I go from 25 to 30. So that's going to be from here on. And in that, I've got 42. So that's going to be up to here. So it's basically right after the 25, my next one starts here. That's going to be 42. I go over to 30. There's my next bar. 31 to 35. So we continue on there. We've got 60. That's going to be up to here. And that's just going to be this next section here. So 35 up to 60. And I'm going to shade that. 36 to 40, and that's only up to 8, so it's going to be way down here. So it's going to be just about there, a little over the 3/4 way up. And there we go, about 8. Then I've got 41 to 50. So now what happens here is this is a bit of a jump. That's going to go up to here, and I've got 36, so just over the 35 mark here. Yeah, and that particular bar is a fair bit thicker than the others, twice as thick as most of those. Okay, then I go from 51 to 60, so here's another big jump, and that's 54. So that's going to go up to just below the 55 mark here. And again, this one has got a width of 10. Okay. And then finally, from 61 to 70, another jump of 10 here. And there's 50 there. So that's going to go up to this mark right here, and I'm going to stop at 70. Shade that in. Okay, and there you go. Now, again, I could have done this a little bit better if I'd used a ruler. But you get the idea. The bars are right smack up against each other because where one age category ends, the other one begins. Okay? And there you go. I hope that makes sense.